Okay, so we're gonna factor. Boy, Emma, I had no idea where that is. I'm sorry. I will. Here, take a picture of the key, so in case you wanna study, you can. Do I have a grade for you in there? I did. That's weird. Okay. All right, so do you have this thing factored, guys? You take a 3 out of the top. And it factors into x plus 3, x plus 1. Take a 2 out of the bottom. And it factors into x plus 1, x minus 1. All right. What are we noticing now once we get our problem factored? We're going to have a hole. And the hole is going to be where x is -1. Remember, denominators can't be 0. So if these didn't cancel, wouldn't we have an asymptote at -1 and +1? But because that canceled, we still have action at -1, but it's not an asymptote now, it's a hole. To get the y, we plug the -1 in here. So we just figure out what is that. So that works like 3 times 2, 2 times -2. Did you get -3/2? Now your vertical asymptote, there's only one of them, and it's where x is 1. And your horizontal asymptote, you can look wherever you want. It's probably easiest to look at the original. You see your your horizontal asymptote is y equals 3/2. It's possible, obviously, that nothing will cancel. If nothing cancels, then you simply don't have any holes, right? Okay, who else found something somewhere on a review sheet or something? Who found anything? Anywhere? Yes, Emma?
3 on the speed dating, number C, the letter C.
Oh wait, you don't have the paper. So,
It was just that.
are you talking about
Yeah,
this? Okay, so when we have a picture, which, sometimes we have pictures, sometimes we have equations. Okay, and the question says, okay, what does the question say? Find the domain. Domain's which letter? X. So X is this way. So what's the farthest left this picture goes? Should be -5 if I counted right. -5. What's the farthest right this picture goes? Infinity. So your domain is -5 to infinity. Now, what would be the range in this picture? Well, what's the highest the picture goes? 3. What's the lowest the picture goes? So the range would be -infinity to 3. Would you agree with that? Yeah. All right, who else found something somewhere? Katie?
Can it be on the review sheet?
Could be anywhere.
Okay, the last page of the review sheet. Number 3.
What does the question say? Which question you looking for? This one? So the question is, so if you can find this, it's on the random practice worksheet. If you can't find it, that's fine, just write it down. So you're given 3 functions, and you have to find C of H of S of 4. C of H of S of 4. That's the problem, okay? So this is a composition. When we do compositions, we start here. So the first thing we're gonna do is find S of 4. What happens when I put a 4 right here? What does S of 4 equal? 2. What does S of 5 equal? 2. What does S of anything equal? 2. So this is a constant function. It's always gonna be 2. No matter what you put in, it's gonna be 2. So S of 4 is 2. Now, what do I do with that 2? Plug it into H. So H of 2 is what? I heard somebody say 36, and I love you because you squared first, which is what you should have done. So we square first times 9, yep, 36. And then C of 36 is a little math, yeah, 73. So the answer to the problem is 73. Katie, was it that first step that was messing you up? A constant function, when you evaluate a function, you substitute in whatever your number is for x. If there's no x, then it's just what it is. Kara?
So like those, you would just do it from right to left, basically?
No. Yes, this way. Yep. Always start with the number, or with the letter closest to the number.
Okay.
So backwards.
On the review number 5, letter D.
On that same sheet?
It's on the front side. It's like the opposite.
Alright, so it's on the front side. Okay, which of that do you wanna do? D. Okay. So this is basically, Amanda, this is the same thing. So she's looking on the front side of the review. It says chapter 1114 review, and there's a heart with period 5 on it. This is the problem. And she wants to do the one that looks like this. Oh, that's a 4. Which, by the way, that same problem could be written this way. The notation is interchangeable, but it means the same thing. So just like as we did with Katie's problem, we're going to take 4 and put it into G. So what do I get when I put 4 into G? 32. So G of 4 is 32. Then, Amanda, I take the 32 and plug it into F. So that'll be, what is that, 1/16, 2 over 32, 1 over 16. Got it, or is there more to that? Are you okay with that, Amanda?
Yeah.
Okay, all right.
So, for example, is that like, how do you find the domain of range of that?
Of, well, that I can't, cause it's just a number, but you mean the domain and range of these individually?
Yeah, it just says domain and range.
For F, or G of F of X. Okay, so using those same two functions, what's g of f of x? Well, you do the same thing, only you don't have a number to plug in, right? Instead, you're gonna plug the whole f thing into g. So we're gonna take the whole f equation, which is 2 over x, and we're gonna plug that into g. So this means take f and plug it into g. That's what this means. Put f into g. So I take my f equation, no numbers this time, f equation, and plug it into g. So then I have 2 times what? 4 over x squared, which is 8 over x squared. So that would be, that's the composition. Okay? Now, tell me about domain for that. That should be an easy question for you. Tell me about domain. No. What do you know about domain? Denominator cannot be 0. So if the denominator can't be 0, then x can't be 0. So your domain is everything from negative infinity to 0, or from 0 to infinity. In other words, everything except 0. That would be your domain. Now, range is a little bit tougher. So a couple of different things. If you want to graph that on your calculator, maybe you could figure out the range from the picture. Or just think about, what do you know about this fraction? What do you know about 8 over something squared? Won't that fraction always be positive? And if it's always going to be positive, then that means it's always going to be greater than 0. So your range is everything from 0 to infinity. Your picture would tell you that too, but this one I think we need to reason it out.
So would you do it in integral definition?
Yep. You're always gonna answer everything in integral notation. All right, what else have you found, Van?
Number 4.
Okay, cross that out. This is, yeah, those are review problems, so we're not gonna do those, okay?
Number 8
I
on
mean,
that
the
same
review for
page.
chapter 2. Number 8. Describe the impact of the numbers. Okay, Charlie, I think you can do this. What shape is this? Is that a 5?
It's a 5.
Okay, well then we don't know what shape it is, but it doesn't matter. Whatever shape it is, what happens when you put a -2 in parentheses like that? What's it gonna do? Take you 2 units to the right, and then take you 3 units down. So the 2 moves us 2 to the right, and the 3 moves us down 3. Yep. That shape will be very much like a cube shape, but you're not required to know that. It wouldn't make any difference what that was. The impact, that would be a parabola, but the impact is the same. No matter what the function is, the impact is the same of those two numbers. Okay, all right, what else? Good questions, good questions. What else do we have?
Can we do one of the questions on 1.4?
We can do anything you
Okay,
want.
can we do D on the 1.4?
So 1.4 homework,
Yeah,
and which one?
it's just the D of it.
Okay. All right, so this is kind of a common theme. Let's make sure we're all clear on this. Oh, shoot, I was over there. I need to stay over here. G of F. And my functions are, F is 3x minus 8. and G is 2x squared. And those are the only two I need for your problem, okay? This is another way of writing G of F of X, which is another way of writing G of F of X. All of these mean exactly the same thing. So in other words, we're going to take F and plug it into G. So we're going to take our F function, and plug it into G. So, G of 3x minus 8 will be 2 times 3x minus 8 squared. Just take F, the F equation, and put it into G in place of the X. And then FOIL it out. And distribute. And that should be your answer right there. I hope I multiplied right.
Can you leave it like that?
Hmm?
Can you leave it like that?
How would you, what else would you do with it?
I don't know.
Yeah, no, this is it.
So
That's it.
I have a question on that. So when we plug in F and G, when we put the G value, why would we put 2 instead of 2x squared?
Whatever you're plugging into the function goes in place of the X. That's how functions work. So whatever you're plugging in goes where the X is.
Okay.
Okay? There's no more X when you plug it in because you replaced it with something. All right, who else has something? Anything like you're doing? Review sheets, homework, anything. Nyla?
Number 4 on the
Okay, we're not doing that. So those are review problems, but we're not, they're from chapter P. I don't want to do those. So it's on the first, on the 1-1 to 1-4 review, Heart period 5, it's number 4. We're solving some random equations. Those are from chapter P. We already took a test over those.
So you're gonna be on the test, yeah?
What did I just say?
Trying to figure
You haven't even asked a single question. Come on.
Everyone's
Engage.
asking before.
Carol.
That same page, but 10.
All right, says, each of the functions in number 9, oh, is bounded above, bounded below, bounded, identify the bounds of each. Okay, so you've got this one, and this one, and this one. And apparently these are all bounded somewhere, which means they have a ceiling, or they have a floor, or they have both. So what shape do we have right here? A V, but he has been moved up 2. So isn't he bounded below at 2? His lowest point is 2? So he's bounded below at 2. All right, what's this one look like? It's a parabola, move 2 units to the right. Or 1 unit to the right, 1 unit to the right. He's also bounded below at 0. His lowest point is right here at 0, right? Now, what about this guy? Now stop and think for a minute. He's definitely bounded both. The normal sign is gonna bounce back and forth between 1 and -1. So the normal sign would be bounded below at -1 and above at 1. But what have we done to it? Down 1. So now it's bounded above at 0 and bounded below at -2.
Would I write that as y equals 0 or is 0 just fine?
Normally we would say bounded below, well, this one, bounded above at y equals 0, bounded below at y equals -2. That would be the official way of writing it. Okay, so boundedness is one of those words, those function analysis words, but it shouldn't be confusing. Boundedness means you have a top or a bottom, right? You have a highest point or lowest point or both. Okay, Kara?
It's on the inside, it's the period 5 part plus phase
Yep.
number 1 on the right side.
So it's extra review.
Yeah.
Okay, number 1 on the right side is the answer to number 1 on the left side.
Oh, that
So
was.
those are the answers.
Okay.
Okay, so the question says, what's the domain of that function, let's say? So we talked about that. Domain, the denominator cannot be 0, so x cannot be -2. I like to do that number line, you don't have to. X can't be -2. And then whatever is under the radical has to be greater than or equal to 0. So be careful when you do this. X is less than 5/3. So here's 5/3. So my domain will be everything from -infinity to -2, and then from -2 to 5/3. For that problem. Got it? Sorry about that confusion. Okay, Nate?
On the back page of the review thing, can you do 3B or just 3 in general?
Were we graphing?
Yeah.
Okay, we want to do A or B.
B's fine.
All right, so this is a piecewise function. I think I'm looking at the right paper.
Yeah.
So I'm gonna graph a piecewise function. All right. So I don't know what your strategy is. I'm gonna put my squiggly line at -2. That isn't part of my graph, but that's gonna help me get my dots in the right spot. Because I know when I do a piecewise function, I've got a dot, a piece, and a dot, and a piece, and things going all over. Okay. What shape is that guy? He's a V, centered or vertex at the origin. He intersects my squiggly line right there. Open dot. And I'm gonna keep the left side of that graph. So this is not even there now, this is gone. Because it says, I want the part of the absolute value that's less than -2. Okay? Middle equation says y equals x plus 1. What does that look like, y equals x plus 1? It's a line normally through the origin, but because of the +1, it's now up 1. Right? And it hits right here, equals, so closed in dot. And what do I keep? Only the dot. It doesn't say less than or greater than, it says equals. So only the dot gets kept. All right, what's the third part? That's a parabola. It intersects right here. Another open dot. And I'm basically keeping most of it, right? I was getting rid of this little piece right here. So Meg, got it?
Does it matter if you have the parabolas dot oversecting the line?
The parabola has to intersect the line.
Like they're, look at the circles, if they're on top of each other.
They need to be. Oh, you mean like they're the same point?
Yeah.
Okay, well, they're not the same point because, let's see, that was the V. If you put in -2, you get 2. But here, if you put in -2, you get 4.
Okay.
So, yeah, you wanna have them, it doesn't have to be perfect, but you wanna have them relatively speaking. Drew, it might help you remember that V's are always gonna be wider than U's, so parabolas, because parabolas are getting squared on those Y values, and the V's aren't.
Makes sense.
Okay, and then are you gonna ask us to find like domain and range for
Might.
that? Okay.
So domain is a no-brainer.
Yeah,
What's your domain?
negative infinity to infinity.
Exactly, because domain is all of the x's that we used, and didn't we use them all? Yeah. Now range, this one's a little bit tricky, because normally when I do range, I say, okay, what's the lowest point on the picture? Well, the lowest point on the picture is this purple dot, and that purple dot is -2, -1. Right, if I put in -2, I get -1, that's that purple dot. The problem is, there's a gap in here, you see it?
Yeah.
So when I write my range, I have to include the -1, not x, y. But then what else? What are my other y values? Well, aren't my other y values everything higher than 0? And that take care of everything? So then I have to say, or, 0 to infinity. So that's a tricky one.
Can you explain why the absolute value one isn't on the x-axis? Why it's like up there?
Well, it was all of this, but it's only, I can only do the part of it that's less than -2.
Yeah, okay, yes, okay.
Meg?
Okay, this last one. So when you were writing out the range, you just write y equals -1, you don't just put the, you don't put point? Like
Range is
-2.
y only.
Okay,
Range is y.
okay,
So
so,
we're talking about the y values only. Right,
Okay.
right. Karen?
Are you gonna have any that are like that complex? Like on the test, like how you have to have like the y equals -1 with the unity and stuff, or do you think it'll just be like?
Well, I don't know. Complex would be like if we put e to the x and sines and cosines up here. So you just need to just look at whatever you've got. Don't worry about it, don't stress about it. Range is y. So which y's did I use? And it just so happened this time I got this random thing down here. If that point had been up here somewhere, then it wouldn't have been an issue, but
Okay.
yeah, so don't worry. Actually, I'm gonna make it as hard as I possibly can because my goal in life is to fail you.
Why doesn't it make it one in brackets or parentheses?
Because when you write an interval, it's gotta have a start and a stop, and the number does not. I mean, it's a number. So, by definition, an interval is from point A to point B, and we only have a,
Question?
Yeah.
13.
okay, I don't know what. Okay, that's left over from chapter 1 also, or chapter E, I mean. All right, who else? Come on, guys, we got 20 more minutes.
On homework 1.3, number 1.
All right, so she's got another piecewise function she wants to do. This one was on her homework. Oh. And this one, not only are we graphing it, but we're doing domain range, discontinuity, and zeros. Okay? So let's get it graphed first, because probably if we graph it, we we can answer all of those questions. Actually, this is domain right here, these are your x's, and isn't that everything? If you're less than -1, greater than or equal to -1, you're everything, so that's your domain. We'll graph it and then talk about the other things. Okay, so my squiggly line's at -1. Alright, what shape is that? A line. And we all know what the linear looks like. We're gonna drop that down 1. So it's gonna look like this. Intersects here. Open dot. Keep this, erase this. Alright, are you with me so far? Emma, so far? Alright, what's this other part? That's a parabola. Vertex at the origin hasn't moved or anything. So it's here, right? Closed dot. And keep all that. Now I'll get my squiggly line out again. So are we good on the picture? Alright, here, let's do domain, or excuse me, range. Let's do range. Alright, this is another complicated one because there's a gap in there. See that? So what's my, let's just do this piece. What's my range here? It goes from -infinity all the way up to this purple point.
Yeah.
Now that purple point is part of this equation, and x was -1. So if x is -1, then this point is at -1, -2. So we're going from range from -infinity to -2. That's an open dot, so I'll have that open. And then, where do I pick up again? I pick up again at 0. Okay, our kids, I don't pick up here, I'm looking at y's. So isn't this my lowest y? So I'm going from 0 to infinity. That dot is part of the graph, so I have included 0, that's a bracket at 0. Okay? If by chance we had a different line, and if by chance the line part were up here like this, then wouldn't my range be all real numbers?
Okay, that's what I was thinking.
Right.
So if it was on top, it would be all real numbers.
Because you covered all of this,
Uh-huh.
and then you covered all of
Okay.
this, that's everything.
But because it's below, it doesn't do,
There's
why,
a gap.
why does that matter?
Because there's a gap in there, there's no points in there,
Isn't there a gap in the top one too?
not in y values. This is every y up to this point, and then this is all the same y's beyond that point. Looking at y values. You can have a gap in the picture, but y values are all included with them being up there. All right, do we have a discontinuity in our original picture? Yes, we do. What does it mean to be a discontinuity? Your picture's broken. When I drew it, I had to lift my pencil. Don't I have to lift my pencil when I draw this?
Yeah.
Where do I have to lift my pencil? At the point where my squiggly line is, which is at x equals -1. The picture breaks at -1. What do we mean by zeros? Another word for zeros is x-intercepts. Does that thing touch the x-axis? Yes, it does, at the origin.
This 4, is it always the discontinuity is the number of the equation?
If it's a piecewise function, yes, this is where it's gonna break. Now, once in a while when you graph these, you can have that exact setup, but maybe it ended up looking like this. Then it's not discontinuous, so it still has all this written over here, but because the two pieces happened to join, then that would not have any discontinuity. All right, what else have we got?
On that same homework, 2D,
All right. So this is just a little sketch, and we're sketching e to the negative x. Now, we need to remember that negative signs don't move us. I mean, they don't pick us up and put us down somewhere else. They flip us, right? Negative signs flip us. And it depends where the negative is as to how we flip. So I want you to think about something. Think of your tests of symmetry. We haven't talked about those today, but you know your tests of symmetry. When you change the sign on x, what test of symmetry is that? Y-axis. So when you change the sign on x, what you're doing is taking your picture, okay, this is the original picture, right, the original, and you are flipping it across the y-axis, because that's what changing the sign on x does. So if I take this picture and flip it across, that does not change the asymptote, it doesn't change the intercept, but now it's a decreasing function instead of an increasing function. Okay? Ally? Yes. Okay, who else? Good questions, all good stuff, what else? Jake?
To, on like the front page. Or, on the back page. Like, f of x equal to absolute value of x, is it odd, even, or even?
Okay, I don't see the problem, what's the question? F of
says-
x
Yep,
equals absolute value.
and it says, is it odd, even, or neither, and why?
Okay, well, a surefire way to do this is to do your tests of symmetry. Odd means symmetric about the origin. Even means symmetric about the y-axis. So if you remember your test of symmetry, one option is just to do that, okay? So what does, the equation is y equals absolute value x. What is the test of symmetry for the origin? Change the sign on both. So that equation would be negative y equals absolute value negative x. Isn't the absolute value of negative x the same as the absolute value of x? So this equation, if I get y by itself, this equation does not match the original, would you agree? So that's a no, it's not odd. What's the test of symmetry for the y-axis? So y equals absolute value negative x. Is that the same as the original? Yes. So, answer to the question is, it's even. Why is it even? Because it has symmetry about the y-axis. Now, I think many of you could have done that problem without going through this, because what does that function look like? What is the shape of that function? Isn't that this? Does that have symmetry about the y-axis? Does that have like an axis of symmetry right there? Yeah. So if you said, you drew that picture and said, it has symmetry about the y-axis, so it's even, perfect. this is the algebra. If you need to go through that, you absolutely can. Sometimes you can't tell from the graph, depending on what the equation is, but totally, you do it graphically with this one. All right, time for more. What else? What else? Okay, this is one of the ones, one of the last things we did. This is where you gotta do it backwards. So we know that Q of P of X is 8x squared plus 5. And we need to find the P and the Q that would combine to make that happen. So in other words, somebody has built a composition. Here it is. And we are to determine what were the two little functions that went together to make that happen. Well, what's going on in this problem? What do we have to do? We have to square, times by 8, and add 5. So there are 3 things that have to happen, but I only have 2 functions. So maybe I'll let P be the function that squares. P has to come first. So if P is the function that squares, then Q has to do the other 2 things, which are times by 8 and add 5. So one option, one possible answer. You could also say, well, but I want P to do the first 2 things. So P has to square and times by 8. And then Q would do nothing but add 5. Jake?
If it had no square, if it was just 8x plus 5, would it be like 8x and x plus 5?
Yep. Yep. And you wouldn't really have a choice on that one because
Yeah.
you have to go in that order. Yep.
We do more of those.
What?
We do a couple more of those. I want to ask the same.
So let's say A of B of X is X minus 2 over 7. So look at your composition. 2 things are happening. We gotta subtract 2 and divide by 7. And we gotta do it in that order, which means that B has to subtract 2, and A has to divide by 7. Not really anything else to do with that one.
This one,
Uh-huh.
on that one, how do you know which one, is like the first variable or the second? Is A first because it's on the outside?
Oh, no. Well, when you do a composition, whatever this is closest to the X, that's the first operation. So in this problem, the first operation is to subtract 2.
Oh, okay.
Right, if I said put 5 into this, wouldn't you do 5 minus 2? And then divide by 7? So whatever this is, has to be the first operation. I'm trying to do a 3 part. Okay, my notation is terrific, but let's say that's 5x squared minus 8 over 2. So this time I got 3 functions. All right, I'm gonna find P and M and N. And I gotta start with N. So what's the first thing that has to happen in this problem? Square. So I'm just gonna let N be the squaring. Now you've got choices. There are lots of ways to answer this, but just go with me. First thing we're gonna do is square. What's the second thing that happens in this problem? Times by 5. So I'm gonna let M be the timesing by 5 function. Now, what else has to happen? I gotta subtract 8 and then divide by 2. So P is gonna be the function that subtracts 8 and divides by 2. If you take this and put it into M, you get 5x squared. Then you take that and put it right here, and you got 5x squared minus 8 over 2.
So there's multiple ways that you could like.
Multiple ways, grading nightmare. Okay? Alright guys, tomorrow's test day. Remember, we will eat last lunch tomorrow, so plan accordingly. If you